Hello, welcome. This is 2.1 Exponent Properties for Math 2 Honors. First, we're going to talk about the components of a radical. A radical, you may have seen some kind of radical is the square roots, but there are other kinds of radicals also. This R refers to the index of the radical, and the P is the power or the exponent. And so that R, the index, we might see it written as like the rth root of, in this case, x, or x to the p. So like if we have 3 as an index, let's say that's the third root of 8, and it asks the question, what number multiplied by itself 3 times gives us 8, and that is equal to 2 because 2 cubed, 2 times 2 times 2 equals 8. And so the third root of 8, or this is also called the cubic root of 8, is equal to 2. A radical can be written as a term with a rational exponent. The r becomes the denominator and the p becomes the numerator. So we might write here the index of the radical becomes the denominator, while here we're going to say the exponent under, instead of, we're going to cross out the of, under the radical becomes the numerator, or the number on the top. Also, I think it's important to note also, if you have the rth root of x and it's all raised to the p power, that's also equal to x to the p over r power. So the p can be outside of the parentheses, or it can be inside, and it works the same either way. All right. So let's see. Do some quick examples here. Convert the following expressions from exponent or radical form. So we have the quantity 4r raised to the 4/3 power. And so we can go backwards and say, hey, that 3 is our index. So that's the third root, or the cubic root of 4r inside parentheses to the 4th power. And that would be equal there. Over here we have a radical, the 6th root of k, all raised to the 5th power. So we can write that as k raised to the 5/6 power. So we're converting it from radical to rational exponent form. And then n to the 1/4, that's equal to the 4th root of n. Since this numerator is 1, it's the same as having a 1, so typically you're not going to see it written. We could write it there, but like I said, most of the time we won't. And then we've got the cube root of 7v, all raised to the 4th power, and so that's 7v raised to the 4/3 power. Alrighty, and now we flip your notes over. If the exponent on a term is of the form m over n, and n cannot be equal to 0, then the number is said to have a rational exponent. So 8 to the 1/3 power is an example of a constant with a rational exponent. 8 to the 1/3 power, by the way, 8 to the 1/3 power is the same as the example we gave on the other page. That's the cube root of 8, and that's equal to 2. Because 2 times 2 times 2, the number multiplied by itself 3 times, is 8, and so that's 2 cubed, which is 8. All the same exponent rules apply with rational exponents as they do with integer exponents. So let's see some examples here. X to the a times x to the b is equal to x to the a plus b. If you multiply like bases, you add the exponents. So let's see here. Z to the third times z to the eighth, that's z to the 3 plus 8, or z to the 11th power. Numeric example here, I've got 5 to the 6 plus negative 4, which is equal to 5 to the 6 plus negative 4 is 2, so that's 5 squared, which is equal to 25. In the case of rational exponents, if you've got x to the raised to the a over b power times x to the m over n power, because they are like bases, we add the exponent. So you have a over b plus m over n. Now you do have to keep in mind that you cannot combine them to a single number unless you can find a common denominator, or until you find a common denominator. So in this case, this is x to the 1/2 plus 1/4, which is equal to x to the 2/4 plus 1/4, because 1/2 is equal to 2/4, which is equal to x to the 3/4 power. And then down here with a numeric example, we've got 3 to the 2/5 plus 1/4, which is equal to 3 to the see, check my notes here. They both have a common denominator of 20. And so this is multiply 5 times 4, you get 20. 2 times 4, you get 8. So that's 8/20 plus 5/20, which is 3 to the 13/20 power. Okay. And then what happens when you divide like bases? Well, if you multiply like bases, you add the exponent, so it makes sense that if you are dividing like bases, you'd subtract the exponent. So we had x to the a minus b, and this is m to the 10 minus 3 power, which is equal to m to the 7th power. And then a numeric example, 4 to the 8th minus, and then you've got a negative exponent down the bottom, so it's minus -3, and that's equal to, minus a -3 is +3, so that's +3, which is 4 to the 11th power. And that's equal to 4,194,304. All right, if we look over the other side here, same thing applies when you're dealing with rational exponents. If you're dividing like bases, you subtract the exponents. So here I've got, now I'm going to add a 1 here to the v to the 1/2 power because there's no coefficient. So you can always assume there's a 1 there in front if there's no other number. So now I've got 1 over 2, which is just 1/2, and I'm going to put that sort of to the side. And I get v to the 1/2 minus 3/2, and that's equal to 1/2 to the 1/2 minus 3/2. They're like denominators, so you can subtract them. 1 minus 3 is -2, so you get -2 halves. And you can simplify that. -2 halves. -2 halves equals -1. So you have v to the -1. And what that means is then the v becomes positive up down in the denominator, and we'll see that in another example here real quick. But that's what it'd be, 1 over 2v. Okay, so we move down. You have a power of a power. You multiply the power. So x to the m raised to the nth power is equal to x to the mn, or m times n. So let's see a quick example here. N squared to the 6th power is n to the 2 times 6th power, which is n to the 12th power. And then in a numeric example, we've got 8 to the 3rd, or 8 cubed raised to the 4th power is 3 times 4, and that's 8 to the 12th power. And 8 to the 12th power is pretty big, so I'm going to put is approximately equal to 6.87 times 10 to the 10th power. That's an approximation. It's a pretty big number in the billions. And then we've got rational exponents. Same thing applies. You have a power of power, you multiply the power. So when you multiply fractions, ab times a to the m is am times b over bn. And so here we get n to the minus 3 halves times minus 1 half, and that'd be negative times a negative is positive, and 3 times 1 is 3, and 2 times 2 is 4. So you get n to the 3/4 power. We look at the next rule here. We're dividing, we have a power of a quotient is the same as a quotient of the power. So we've got x over y to the nth power is x to the m divided by y to the m. And that would mean here we'd have 3 to the 2 times 3 power over x to the 5 times 3 power. And that would be 3 to the 6th power over x to the 15th power. And 3 to the 6th is 729 over x to the 15th. And then that still applies when you have rational exponents. The same thing applies. You multiply the exponent on the outside by each of the exponents of the parts on the inside. So that would give us x to the 1 half times negative 3 halves over x to the minus 1 half times negative 3 halves. And that would give us, let's see, x to the a positive times a negative would be negative, so that's negative, and then 3 times 1 is 3, and 2 times 2 is 4, so negative 3/4. And down on the bottom, a negative times a negative is positive. 3 times 1 is 3, so x to the 3rd power, 2 times 2, 4th power. And we can simplify that, bringing the negative 3/4 down, so it'd be 1 over x to the, if you bring this negative 3/4 down, it becomes positive. Again, we're going to go over here this in just a moment. So that's 3/4 plus 3/4, which is 6/4. And then raising the power to the 0 power. Anytime you raise something to the 0 power, you get 1, with one exception. X, your base, cannot be equal to 0. So you cannot take 0 to the 0 power. That would be undefined, because if you think about, if I have, let's say, 3 squared divided by 3 squared, from our last example here, not our last example, but one of the earlier examples here, when you're dividing like bases, you subtract the exponents. So this is the same as 3 to the 2 minus 2, which is equal to 3 to the 0. But 3 squared is also equal to, it's also equal to 9. So I have 9 divided by 9, and when you divide a number by itself, you get 1. And so anything divided by itself is 1. So because it's rooted in division, you cannot divide by 0. And so this part right here is an important thing to keep in mind. Your base cannot be 0. Here, 4 is not 0, so 4 raised to the 0 power is 1. And this works with rational exponents as well. It doesn't really matter too much what we have inside here, so long as it's not equal to 0. You raise it to the 0 power, it's going to be equal to 1. Okay, and then finally, negative exponents. The negative exponent means the reciprocal. You got x to the minus 1, that's 1 over x. If you have 1 over x to the minus 1, if it's negative down in the denominator, it becomes positive in the numerator. So z to the minus 3 is 1 over z cubed. Here I've got 3 over n to the minus 4. So if it's negative down here, it's positive up here. So this just becomes 3n to the 4th. And that would be how you would simplify those. Let's do another one here. 5x to the minus 8/3 power. That's it's important to realize that this exponent, negative 8/3, applies only to the x. It does not apply to the 5. For it to apply to the 5, you would have to have it in parentheses like that. But since we don't have that, what we get as a result when we're simplifying this is we get 5 stays on the top, and then we get x to the 8/3 power. It becomes positive down in the denominator. So over here, let's say we get 1 over 4x squared raised to the 3rd power, and that's equal to 1 over 4 cubed x to the 2 times 3, or 6 power, and that's 1 over 64 x to the 6th. And then on the bottom, when you have a negative power like that, you can get rid of the negative by just switching the numerator and the denominator. And so we can write this as x to the minus 6 up top, 4 on the bottom. Instead of raised to the minus 3rd power, it's just raised to the 3rd power, because we use the negative to get the reciprocal of what was inside. Then we just say this is x to the negative 6 times 3 is negative 18 over 4 to the 3rd power. This 4 cubed is going to stay down here, but we'll go ahead and multiply it out. It's 4 times 4 times 4, which is 64. But then this x to the minus 18, because it's negative up here in the top, we bring it down here, x to the 18th in the denominator, and then we're left with a 1 up in the numerator. When you're left with the 1 in the denominator, you can just cancel it. But when you're left with the 1 in the numerator, you have to leave that 1 there. And that's what we'd get. All right. Thank you.